Hi everyone, I'm Bihan Chakraborty and today I'll be discussing LeetCode's 560 problem, that is Subarray Sum Equals K. So this is, I think, February 22's day 10 problem, and let's see the problem. So yeah, here we have been given an array of integers norms and an integer k, and we need to return the total number of subarrays whose sum equals to k. Okay, so there's one observation here, that is subarrays. We haven't been asked to find subsequences, okay, and subarrays are always contiguous. So we need to find the total number of subarrays whose sum equals to k. So that means sum of all the elements in that subarray equals to k. So let's see the examples. Let me zoom in. Did I zoom in? Yeah. Okay, so 1 1 1 and k equals to 2. So what are the possible subarrays? These two elements can make a subarray 1 plus 1 equals to 2, and these two can make another subarray 1 plus 1 equals to 2. But this one and the third one cannot make a subarray, obviously. That would be a subsequence. But we need to find subarrays. Okay, so the answer is 2 here. Here, this is one subarray of length 1. Okay, and this 2 plus 1 3 is also another subarray because k equals to 3. So answer is 2. Okay, so 2 subarrays are possible here. So how do you approach this problem? Okay, let me go to my editor here. So suppose I have 8 elements a, b, c, d, e, f, g, h. I am not using numbers here because this is a general case and I want to show it to you properly. So suppose I am at g. Okay, I am at g. Let me change the color. Suppose I am at G and the sum of all elements from A to G equals to S. Okay, S, or let me write it as sum. Okay, sum is sum of all the elements from A to G, A plus B plus C, like that up to G. So now suppose there's a subarray of some k here, or let's say here. Okay, let me do it above. EFG. Okay, the sum of these elements equals to k. Now, how can we find this element in of n time? I'm getting to the time complexity later. How can we detect this subarray? Suppose I am here. If these three elements sum equals to k, I can say that the sum of these four elements a, b, c, d equals to sum minus k, sum minus k, right? Because the sum here is k, this whole sum equals to, sorry, this whole sum equals to sum. So I can deduct this k from here, then we will have the sum of the remaining elements here, right? So we can say that at any ith point wherever I am at, if I can find a point where sum minus k sum was there, I mean for every ith element I have a sum, definitely sum 1, sum 2, sum 3, sum 4, like that. And for every sum, if I deduct k and check if previously I had an value x equals to sum minus k, I mean if at any point before I had a sum, like that can be sum of I equals to x, if that was the case previously. Now how can we store this previous thing? We can do that using a hash map. If not hash map, we can loop it, like at any ith point we can again start from here and again check up till here, where at which point this x equals to sum minus k, but that would make the time complexity of n squared because there would be a nested loop, right? So to avoid that, we can use a hash map, that is for every iteration we will store the sum. Okay, let me write here. At every step, okay, let me reduce the font, it's too big. Yeah, so at every step we insert the sum in map. Okay, now then what we do, this is the later step. Okay, initially we check that at the ith step have we like encountered any sum before whose value is current sum minus k. So check if, so what is this? Sum of j equals to sum of I minus k. So sum of I is my current position and j is any previous position. We're checking for every j from 0 to I exclusive if there's a value that is sum of I minus k. Now if that is so, we can like think like this, we can remove those elements, all the elements which equals to sum of j, we can remove all of them, and what we will have, we have only the elements whose sum is k, so we increment the counter there. Okay, so let's see the code. The code is very short, the explanation is more here. So we have a hash map and answer will store the count and sum will store the sum at every loop, at every step. Okay, so here we like first of all we will add the number to the sum, then we will check if hash map contains sum minus k value. If it is there, we increment by its frequency, we increment the answer by its frequency. After that we check if sum equals to k, that means from 0th position till my current position, if the whole sum equals to k, then if all the numbers equals to k, then I simply increment by 1 because that is the only one possible subarray there. Okay, so that is done. Then after that, hash dot merge, that is we increment the sum, this is for C++. Okay, so we increment the counter for sum in my hash map. So this is the problem, guys. If you have liked the video, please like and subscribe to my channel, and if you have any doubts regarding this problem, please comment down below. And yeah, see you in the next video.